In this video, we will provide an example of how to use the load combinations to ultimately calculate the value of the required moment using LRFD. To begin with, we have a beam that is subjected to a uniform load. The service dead load is 1.5 kips per foot, and the service live load is 3 kips per foot. Since this is an LRFD problem, we will use the LRFD load combinations, and we will plug the service dead load of 1.5 kips per foot and the service live load of 3 kips per foot into the corresponding 6 load combinations that you see on this slide. After plugging those values in and calculating the various load effects from each combination, we choose the biggest load effect that is given or produced from these 6 combinations. In our case, the second load combination produces the maximum effect of 6.6 kips per foot. We then take our beam, 15 feet long, and subject it to this factored uniform load of 6.6 kips per foot. Then we proceed with calculating the reactions, which in this case would be 49.5 kips at both the left and the right reaction, and then develop a shear and moment diagram based on those reactions. The shear diagram goes up to the reaction force of 49.5 kips and then slopes down under the effect of the uniform load for the rest of the length of the beam until it gets to the right hand reaction, in which case the 49.5 kip reaction puts the shear diagram back to 0. Shear diagram crosses 0 out in the middle of the beam. To find the moment, which in this case is m sub u, I simply calculate the area under the shear diagram. Since this is a triangular area, the area is simply 1/2 base times height. Our base is 7.5 feet, and our height of this triangular area is 49.5 kips. Taking 1/2 times 7.5 feet times 49.5 kips, we find a maximum moment, mu, on this beam as being 185.6 foot kips.